So, to go over this question, if we had an incline with a block over there, um, the question says a force of magnitude T is equal to 312 newtons up an incline is required to keep a body at rest on a frictionless inclined plane, which makes an angle of 35 degrees with horizontal. Calculate the magnitude of the force due to gravity and the normal force, giving your answer to three significant figures. Okay, so if we do this question, just throw a box over there, and this is being pulled up at 312. This is 35. So if we make a force going straight down, that's going to be equal to your weight. It's W. This is going to be 90. So 35 plus 90, that gives us 55. And then we make our normal force, which is perpendicular to the plane. Okay. So this is also 90. This is our normal force. And this is going to be 55 due to alternate angles. That's 55 and then this is 35. Okay. So if we want to calculate, so we can see that this force is going to be parallel to the plane. This is force TA. So what I'll call this the force which is parallel, the parallel force. So we can see, so we calculate the sum of the horizontal forces, and these are all meaning horizontal to this inclined surface over there. So we can see it's just it's T plus T, and this force is the force which is also due to gravity, which is going to make this block want to tend to fall down that way. Okay, so we can see T is going to the right and this is going to the left, meaning this is going to be negative, and that is going to be equal to 0 because this block is stationary. So the sum of all this is equal to 0. So we can see that T is going to be equal to PF. And we can see that T is equal to 312, meaning PF is equal to 312. Okay. Let's just put this over here at the bottom. Okay, so now we know that this W force, W is going to be equal to PF sine 55, right? Which is this angle over there. Okay. So we know that PF is, sorry, not W sine, W cos. Sorry, we know that PF let me just check this quickly. Let me just double check it quickly. W cos theta, which is equal to 312. Okay, so so we know PF is equal to W cos theta, and we know that PF is equal to 312, right? So to solve W cos theta, that is going to be equal to 312 divided by cos theta, which is equal to W. Okay, so W is going to be equal to, let me just check quickly, 543,955. Okay, so we found the force due to gravity, and now the normal force. And the normal force is just going to be equal to W sine theta, or sine 55. So the normal force is equal to, and we've calculated W, 543,955 sine 55. And that gives us 445,58. This is in newtons. Okay. So like I said, first we wanted to find the sum of the horizontal forces, meaning the forces horizontal to the plane, and we can see this block isn't moving, so we said that it's going to be T minus PF. PF is going in this direction, P is that direction, and these two balance each other out. T minus PF is equal to 0, and it's 0 because there's no acceleration, or there's no forces, and this thing is balanced. So if we want to find PF, PF is going to be then equal to TA, because these two forces balance each other. Okay. The next one, we wanted to find W, and we know that PF is also equal to W cos theta, right? Because we're breaking this weight into its components. If I just move this over here a little bit, okay, I think let's just move it like that. We're breaking that triangle, that small triangle, into its components. Just draw a line here, separating everything. Okay, so I'm going to draw this little triangle over there, just so you can see it. Okay, so this is 55, 35, right? And this is that W force. And this W force is going straight down, like we said. Okay, it's going in that direction. So if we break this into its components, this is W cos theta, and then this is W sine theta. And we broke, like I said, we broke those two up into its components. This is 90. Okay, so, but this is W cos theta, and this is equal to 312, because it balances that top one out. Okay, so now we can solve W. We know that W cos theta is equal to 312. We divided by cos theta to find W. W is equal to 543,955. And then the normal force is W sine, like we said, W sine theta. So we just multiply the weight times sine theta, and then we get the normal force. Okay.